Hey guys, sorry for the wait. I was really late today. We were watching the final episode of The Boys. Who's been watching The Boys? I'm glad my OBS changed. Something like that. This is a power supply. Do I need this today? No, I don't. And we actually had something weird happen, which kind of threw me off schedule. Let me try and synchronize that image, and then I'll show you on the stream. Because I'm wondering if anyone's ever seen this before. Yeah, we just finished the last season. So I can always not really tell, is the music at a good volume right now or not? Also go here, I still need to clean up the last Queen box. Bad. Okay, sure, this will work. Okay, let's see if I can get this image in here somehow. Board like Dig Uno, but LED output and ESP powered over PoE++ LAN. Sure, but are you willing to pay $100 per port for that motion graphics? Hold on, trying to find it. Stop it, go away. Okay, let me try and share a window. Let's see, window capture. Whatever. Okay, it's showing up as a black. Of course it doesn't work. Why would it? Does it work now? No? Does it work now? No. Why not? Oh, such great. Okay, let me try and fix this somehow. Capture method. Windows. Oh, there we go. Okay. So this is a photo of our bathroom. And I was sitting downstairs actually making the thumbnail for this live stream, and we heard a giant bang and all kinds of noise, and then we ran upstairs and we found this. And I mean, this has been in place for 8 years. We were both downstairs. There was no one upstairs. Nothing was going on. It just exploded. Has anyone seen anything like that before? Yeah, well, we spent like 2 hours trying to clean it up, and it's bouwvak, so it's like the builder vacation, so who knows when we'll be able to get someone in here to get a new screen. Yeah, but Neil, I get that, but there was no one there. I mean, literally, we were both downstairs. The cats were downstairs. There was no one upstairs. It just exploded. I mean, we have no idea what happened. And yeah, it's tempered glass, so it's like everywhere. I did still manage to cut myself, though. The house shifted. I mean, it's not impossible, but I don't know, man. They have been doing construction work like 50 meters from the house, but that's been the haying, so the poles in the ground and stuff, that's been finished for like a month now or so. It's just gone. Kablooey. A glitch in the Matrix, yeah. Just buy a new house. Working on it. Yeah, this and there's glass shards everywhere. Okay, let's delete this again. Remove. Yes, there. So I did manage to hurt myself. So this part started bleeding pretty bad, and I cut my finger. There. There. You can see the cut. But and I think I got like a wound here. So even if it's tempered glass, you can still get cut. Well, if you're, you know, like me. Maybe a volcano brewing under your house. Yes, that is the best explanation I've heard yet. Yeah, so motion graphics, we have investigated PUE solutions before. We actually did a live stream not too long ago about using PUE++, so BT, the 90 watt variant. And you can already do so with the current boards and external PUE extractors that then take in the 42 to 52 volt and output 12 volt. I've articles about this too. And you can get the 90 watt if you have the right equipment. But just for the switch port alone, if you want to do this on a larger scale, you're going to need a switch that can do like 1,000 watt plus. Well, now you're spending like $2,000 just to get that switch. And then you're still power limited to 1,000 watt. And then the equipment you need on the receiving side will cost you, let's say, $50 at least for the PUE part. So now you're in about $100 just to use PUE. And then you still need the LED controller just the same. So it's a really expensive way of distributing power. But I have something in development. I don't have that much news about it yet today, that I'm calling Power Diff, which will basically, this is a prototype board for it, which will basically enable the same functionality, except you don't have to have the intelligence of the controller out in the field anymore. You can keep that localized and run power plus data to the points where you need it over a simple Cat5e cable, and then use it that way. But that's a prototype that's in development, so yeah. Yeah, this prototype works in some parts, but in other parts it still has a feature that it's a destroy itself feature. It's basically not resilient enough yet for hot plugging. If you're not hot plugging stuff, it works great. But if you are, so I'm still trying to solve that. There's a new prototype though that should be coming next week or the week after that. Not sure yet. So yeah, I think I know of a better way to solve that than PUE, because PUE for power-hungry stuff, especially high transient loads, also for like LEDs, it's not that great, and it's really expensive. And then I don't think you'll need to do it for like $100 a piece or a port, but you can do it for like $10 or $20 a port of additional costs. So yeah, it's an exploding smoke machine, Emil. Yeah, that is absolutely in development. Diff. So we already did Diff Solo. Diff Advanced is coming soon. The first ones are starting to roll out of assembly. Now we still need to do the testing and other stuff with it. But those I'm hoping to release next month. And I'm working on the documentation for that. And well, development on all the other stuff, like the other analog boards, those have gone into production this week. And all that stuff's continuing. I'm working on so many projects at the same time right now. It's driving me mad. But yeah, what needs to be done needs to be done. $40 people here, huh? That's okay. That's pretty decent for summer. So the drinks we have today. Let's take a look. Now you can see my patch here because it wouldn't stop bleeding. We have some Coca-Cola Zero Sugar, but then we have the vanilla and the cherry variety. But the cherry is still colder. So I'm gonna drink the vanilla first. Pepsi Cola, I'm sorry. You're in love with the Dig Octa system. Bloody easy. Thank you. I tried to make it, you know, as functional as possible. Sure, motion graphics, I get that use case, and that's a valid use case in my opinion too. But I'd rather not have the logic at the end part if I can have the logic centralized. And that's what I'm working on, with power. So if you want to display like 100 LEDs at 5 or 12 or 24 volt, you can run a 100, or okay, let's say 50 meter Cat5e cable and do that no problem, and the length will vary based on how many LEDs you want to be able to run, but yeah. Hey Tony, welcome. Oh, I didn't do any welcomes. I'm running behind even when I was still here on time. So Draadstraal was here first. Literally, he knows what I mean. And then Chardo, Greg E, Nigel Young. Let's see, Philip is here, of course. Nice. Motion Graphics and Kvik. Neil H. Ucask says ghosts. Who knows? Who knows? Thermal expansion, possibly on a weak spot. Yeah, but it's been in the same place for 8 years. Nothing was there. My girlfriend showered this morning. I showered last night. Didn't notice anything weird. It's just so weird. Anyway, Emil Bart is here. Piotr, lots of familiar names. Foxy 22. Nice. Legal name is Pepsi Cola. Well, if that's the case, I'm willing to be sponsored, although I'll still drink Coca-Cola on stream, or you have to pay me really a lot. You can sponsor me anyway. Yeah, no. Okay, let me check my camera settings here, because it's a little bit too dark. There. That's it. Nice. Good to hear, Pepsi. Yeah, so there's some feature overlap between the Dig Quad and the Dig Octa, but I generally say if you're going to run Ethernet anyway, upgrade to a Dig Octa, because it has lots of ease of life improvements, like better terminals and easier board design and stuff like that. Nice, awesome, Matt. Welcome. No, actually, I just clicked away. That said, it was a good time to insert an ad. Anyway, we're already over time, so what we're going to do... Oh, well, I'm already at the top-down view. That's easy. What we're going to do today is... I was perusing on Aliexpress. Who doesn't? I seem to do this a lot. We're not going to talk about that. And I came across these kind of button boxes. And I was like... That'd be cool if we could use this as a sort of external button box. Like you can program these buttons to do something in the LED controller. Or if the button boxes are big enough, we could even fit like an An-Penta-Mini inside of the box. So yeah, I mean, if you look at this, especially if we take out the bare PCB, might fit. I don't know. And then you can just put power in here and then have the buttons come out of, or the LED data. It's not data, we're talking analog. The LEDs come out of here. But for right now, I think I just want to see if we can use this type of button box for, well, buttons. I think so. But I mean, so these are kind of mushy sounding, and I don't really know how they work. Because if you look inside, they're basically like this plunger type, right? So I get that. But then on this side, there's nothing to push into it, because it pushes into this. But then does this, how does that work? Does that line up in such a way that it actually makes contact? I guess so. I don't know. Right? It's a bit odd. how does this push on this? So I don't quite understand that. And I believe the green means normally open. No, okay, normally open, yeah, so not connected. And NC means normally connected, so normally connected. They are not centered in the... No, I know, but, I mean, does it happen to hit the edge of one of these? Let me do the white one here. I mean... Yeah, I guess so, but... I mean, if you look at it, I guess so. It's hard to show. I don't know, we'll have to trust that. But then we also have these, and these are more... Why am I not 60 FPSing? Hold on. Yeah, okay. Let me do this. And do this. Now we're at 60 FPSing. Okay. These are like... These are springs in them. Hear that? You know I'm a sucker for a good button. I mean... So let's open these up. Oh, they even have label spots. You could label them. These also came with a wortel, a gland, M20 × 1.5. Okay, of course that's very generic for, you know, whatever cable you're going to be using or not using. That's a loud spring. Yeah, well, we might look at that. But so this one has the buttons like units integrated, and each button has 4 posts. So we'll have to figure out how that's connected. So this says 11 and 23, and this says 12 and 24. So I'm assuming, yeah, 11 is linked to 12, and 23 is linked to 24. But then do they switch at the same time, or? I don't know, let's find out. Multimeter mode? Well, you can put the antenna external, right? But I don't know if there's going to be enough room in the box. We'll have to... I mean, this would become the box. You ditch the aluminium casing. Now, I don't really want to do that, but... yeah, I don't think this will fit. We'll see. Let's see. No, so okay, there are some fitment issues here. So with the case, it's certainly not going to work. But without the case, it might. Could even maybe do it... No. Yeah, could even maybe do it like that. It'd be a tight squeeze, but... How's it on this one? Oh, these has the switches on the bottom, so that's going to be a problem anyway. Putting kit! Always good. What was I going to do again? I don't remember. Oh, I was going to multimeter it. Right. So I think I want to use the yellow boxes to start. We might look at the other ones later. We might not. I don't know. So, let's see. Let's see if we can get the multimeter on screen again. Sometimes it's broken. Sometimes it's not. Connect. Yes. Let's see here. Continuity. Okay. So now we, well, you might not be able to hear the beep, but you can at least see it on screen, right? I'll move the yellow box away. There. Good. So, if we take a look at this, and we have 11 and 23 here. Are those connected? No. Are they connected next to each other? No. Okay, that's good. So this is all not connected. Well, okay, this is, of course. So then, is this one connected? Oh, it is. So these two are connected. Okay, this is not. Oh, okay, and these are not connected. Right? So this is normally closed, and this is normally open. And probably, if I manage to do this, yeah, if I press the button, the normally closed becomes open. Right? So if I click it, okay, and this one isn't connected, but it should, in theory, work in reverse. So, yeah. Okay, I generally like that best. So normally it's not connected, or open as they call it, and then you can connect it by pushing the button. Good. Okay, so I'm thinking how we're going to be connecting this. So on the An-Penta-Mini, we have button 1, 2, and 3, ground, and 3 volts at the front. Now these buttons have all been hardware pulled up, so they're linked to 3.3 volt, and there is a little debouncing circuit on it. So what we can do is we can wire up button 1, 2, and 3 to button 1, 2, button 1, 2, and 3, and then wire up ground to each of the other sides, so that when you press the button, it's shorted to ground, because it's normally high, then it becomes low, and that's what you can detect in the ESP. Right? So I think I'm going to focus on the yellow box first, because I kind of think that looks coolest anyway, because this has the the really cool springs here. So let's see how these terminals work. There's a cap here. Should we take that cap off? Okay. Now it's off. Oh, okay, you can see the red and the green. I guess that's the same red and green as is over here, right? Makes sense. I guess you can replace them, maybe? You can also unlatch here, but I wonder how. Oh, we might be able to take the whole button out, actually. There! There is a white springy here you can push, and then you can actually take off the button. So now this is just a plunger, just like on the other one, and the whole mechanism is inside of here. And this is sort of a release for that. Okay, so then you can pretty easily, oh, well, you can even see how it's connected here. You can easily wire it up. Okay, so what are the ratings? 440 volt, okay. AC 12, DC 13. I don't know what that means, and it can do up to 10 amps. Huh. Well, we don't need anything close to that. We need like a few milliamps, but Tintikili, that is our precious heart that we keep in the stream, and you can hit the heart and the button on your side like this, and then it'll appear on the stream, like you're encouraging me. Dremel time? No need for Dremels. What? Yeah, so this just pops in place, I guess. Let me check. Yeah, okay, clicks in place. Yeah, that's a nice system. It's easy. Because now we can work on the button out of the case, and then we can just insert it in the case, and that's it. And I just also, yeah, can just remove them. That is pretty cool, and now it's locked in. Yeah, we might need to drill a hole, but we can punch out one of these round... Oh, they also have them on the bottom. Okay. Oh, they have the dimensions on the bottom. Interesting. That's nice. doing that in the plastic. That's pretty cool. Yeah, we can punch out one of these and then put in one of these cable glands. It won't be great, but you know, we can use some cable sleeving to hide the wires. Hammer time, yeah, maybe. Okay, so I don't know what software is on the An-Penta-Mini right now. I think I want to test with WLED first, and then later we'll move on to ESPHome. But then I need one that's flashed with WLED. No, don't worry, Ben. You're in time. So let me think about how I want to do that, because our web flasher for the An-Penta-Mini isn't done yet. It should be soon, I think, but because we have the firmware we shipped them with. So now I need to use ESPTool, but I don't know if I have ESPTool on this PC. Let me check. ESPTool. I don't. Do I even have Python? Oh, okay, I do have Python. Okay. Pip install ESPTool. Oh, it's already a new release of pip is available. Okay, Python. I guess I should show you this stuff, huh? So we're going to use ESPTool to flash it. Window capture there. So to normally install, you need ESPTool, but ESPTool is a Python tool. So normally you should be able to do ESPTool, but I don't have ESPTool, but I do have Python. Python, there. But it's too old, so I need to update it, it says. Pip install upgrade pip. So let's wait for that a little bit. Sure, if you can put the web flasher on the temp page, that's fine too. Okay, so now I can say pip install ESPTool. Okay, it's already there. Okay, ESPTool. So maybe it's just not in the path. And then where is it? Oh man, I hate this kind of environments. I guess it makes sense for programmers and stuff, but if you're not, it's mind-wreckingly irritating. Like okay, I installed all this crap. It's there. It says it's there. It's working, but it's not working at the same time. It's so infuriating. So then where do I have a Python direct? I have a Python directory here. Okay. So then what? Is it in scripts? Pip, there's pip here. Okay. Is it in lib? Site packages? No ESPTool here. Let's see, auto test. No. So let's see if I get this working first or if Philip finishes first. Oh man, I'm gonna do a really bad thing. Dear ESPTool.exe. I'm just gonna search my whole drive for where the tool is. And we get a drink. Oh, we found it. So somehow I'm supposed to know it's over here, which makes total sense. Okay, so now I have ESPTool. Oh, it even works. Okay, so we found a random path ESPTool is in. So let me dump my binary there. Hold on. So I kind of know how all this stuff works, but I really don't want to mess with it normally. Oh man, okay. So let's put all this here. So now we should have flash.bat. Okay, and that is the whole command line. So now look, let's hook up the An-Penta-Mini. Where is it? There. I have to remove the antenna because I don't have a compatible USB cord here. Because the box is too small to make it all fit, but kind of fits. I have in my other room, I have a USB cord that fits with the antenna, but you know. Okay, turning that USB port on. So in theory, I can now say flash.bat. Connecting. Maybe. Oh, it's connected to another COM port. Nope, didn't work. Okay, why? Okay, I need to check which COM port it is. Hold on. Device manager. Oh, I think it should actually be this one. Yeah, I think so. It's not rebooting. I use KiCad, Tintikili. Yes, it's getting powered over USB, yes. And I mean, the COM port is appearing, so normally that means we have a connection. The FTP is broken again? What? Why? Okay. So I guess we're stuck making this work. What is it doing? It's reading... Okay, let's try and do it again. Doo-doo. Doo-doo. Okay, if that doesn't work, we need to do a little trick. I don't know why it's not working, but it could be that I have borked software on here, because I use these for, you know, development and stuff. So what we're going to do, hold on, is we're going to make a wire bridge. And I have an article about this. We're going to link ground to button 3, like that. And there is an article on the about this in the An-Penta-Mini section on the website. But basically what this does, it forces the ESP into bootloader mode. Doo-doo. So let's try it again. So it won't normally boot. Unexpected UART date code? What? Am I trying to flash a broken board? It's possible. Okay, that's unexpected. Well, we're getting further. Maybe there's a too long USB cable on here. Let me try a different USB port. Yes. Nope. Okay. I don't know if I screwed up this one. Maybe. Maybe I did. So let me get another one. Hold on. This one was on my desk, and most of the things that are on my desk aren't safe to use. So, you know, your mileage may vary. I'm not running CrowdStack, no. Let's try and flash this one. What is going on? Okay, so this one again doesn't have the boot mode, but it shouldn't need the boot mode, but okay, sure. Let's try it like this. Flash. No, somehow this isn't working. Interesting. Is my version of ESPTool too old? Could be. Oh, Philip got it. Philip got it. Okay, let's try his method. So he says he fixed it in a DM. Hold on. Okay, let me. Where is it? Let me then share that window. Nope, that's the chat. Okay, so the pictures and the text is all wrong, but in theory, if I install and do this one. Oh, Philip, my ESP32C3 board does not support it. So it needs some work. It needs some work. We're going back to my command prompt. You get another try, Philip, if you want. Where is it? There. So, pip upgrade ESP tool. Oh, it doesn't know that. Pip install ESP tool. So it thinks it already has the new. How do you upgrade with pip? Pip upgrade. Oh, okay, okay. Pip minus M. No. Yeah, he's what? What's his upgrade? Okay. Ah! We're going from ESP tool 3.0 to 4.7. That seems my... Uh-oh. What? What? So, okay, what? Okay. What? I think it did it, so let's see. But then where is it? Oh my god. Did it change this one? No. Okay, so this installer is from 2020, which makes sense that then it doesn't understand what an ESP32C3 is. So now it installed a new pip, or ESP tool, but we again have no clue where it went. So we're going to do the same thing again. We're going to just search the whole drive for ESP tool. Okay, so now, okay, hold on. So now it's over here. For whatever reason. Okay. There, ESP star. Right, so this is a new ESP tool. So now I have to dump my files in here. Copy. How do they expect normal users to do this stuff? I mean, it just doesn't make sense. Flash. There! Victory! Okay, so my ESP tool version was three years too old. There wasn't a problem with the board. I don't generally use this computer for that kind of stuff. I use my other computer. So, yeah. You use the Windows ESP tool. What? Okay, flashing. Nice. Oh, okay, what Coke is that? This is Coke Zero Vanilla. Right, so now we have a board. Let's put the other board away. I don't know. We have a board that's flashed. We can remove this wire bridge. And this should now be running our, well, let's say factory factory WLED. Come on. Okay. So I can now attach an antenna. And I should attach power. Let's see, what kind of power we're going to connect today? 48 volts? I don't know. Do we have a 48 volt LED strip here by chance? I do, I think. What voltage is this? No? No, doesn't like it? Hello? Okay, yeah, we have a 48 volt LED strip. So we can use a 48 volt power supply. Because I already have that hooked up. I have a, hold on. Whoa. I have a Meanwell UHP 500 at minus 48 here. Badly guarded terminals, but okay, I'll forgive it for that. I think that's actually still plugged in. So we can plug this side here. Okay. And we can then plug the LED strip, because I already have that wired up. So for some reason they use black as the positive on these. I don't know why. Wago for sure. So the black wire actually goes into the red terminal. And we have our triple here, and then we have the dual white here. Right, so dual whites are going to the high power or the medium power channels, and then RGB goes to the low power channels, and that's how you have RGB CCT. The Windows tool flash download is 385. Oh, okay, that's also old. Right, so currently we have the following. We still have this wire connected to ground because we're going to experiment with that. We have an RGB CCT strip with 48 volts, and we have a 48 volt power supply. We have it all plugged in. Although these are pluggable connectors, it's still not recommended to hot plug them. Well, let's see if it explodes. Doesn't explode. Oh, I was going to say it should turn orange, but it just took a little while. Okay, so then where's my phone for over here? Interesting. Oh, here it is. It might not be charged. Okay, let's put that on the charger real quick. It's my thermal phone, camera phone, which I generally use here, but you know, that's okay. Why is it using 15 watts? It's a lot, isn't it? Oh, okay, maybe. Oh, okay, well, the whole roll is, of course, this is analog strip, so the whole roll gets turned on, so we'd better unroll that. I'm saying, what? Why is it using so much? But it's activating all the LEDs because it's analog. But yeah, one of the features of the An-Penta and the other upcoming analog boards is that it's 48 volt compatible, as you can see. Otherwise it would be smoking right now. Okay, well, let's arrange this a little bit different. There. So that the heat can dissipate a little bit. There we go. Okay, cool. Right, WLED. I'll do it on my phone, and I'll join it to the network. Let's see. Right, so we have the WLED AP. So I'll join this to my network real quick, scanning, because then I can do it on screen. So I'll join it to this network, and this has a very secret password here. So you can connect. Yeah, well, you know. Let's see. 10. Okay, yeah, I have a WLED. So let's open the shared thing again and go to this one, I think. Yeah. And make it a little bit smaller so we can see what's going on. There. Okay. So in here we should it should be pre-configured for RGB CCT. So if we do red, that works. Blue works. Green works. This is partly thanks to Paolo. He worked on getting this WLED firmware flashable for the An-Penta-Mini, because the default one doesn't work that great yet. I'll try again later, Philip. And well, we do have effects here, but the list is a lot smaller than normal. We can do color loop, for instance, but other stuff like rainbow we can't, because all the LEDs will always be the same color, right? And if we turn off color and we turn on white, we should have, oh, okay, warm and cold white are reversed. Well, it's just, you know, I need to change the wires real quick. Seemingly, I put them in reversed. I could either change the configuration, so just swap the GPIO pins in LED config, or you can just swap the physical wires, right? So this one goes here. I'm hoping within, let's say, 3 weeks, because we're reproducing them. They are in production, but it always takes a little while. No problem there, Sabulwa. Very kind of you to say. So now if we do warm white, we have warm white, and cold white, we have cold white. Good. But we came here for the buttons, and let's see if we have any buttons configured. We do. We have button GPIO 0, and the rest is unused. Okay. Let me look up the website real quick. So if we go to the website, Analog LEDs, An-Penta, and I know it's a few clicks, An-Penta-Mini, and there are all kinds of guides. Oh, you can't see that, can you? There. All kinds of guides, but one of them is the pinout guide, and then here we can see that GPIO 2 is button 1, GPIO 8 is button 2, and GPIO 9 is button 3. So let's set that. This is 8, and this is 9, and we'll say that all of them are push buttons. Okay? Save. Back. Now, I don't know what they're going to do, but we can simulate the button presses by taking our wire that's connected to ground and touching it to button 1, 2, and 3, and we'll see what happens. So let's touch button 1. Okay, turns off. Button 1 again. Do I need to hold it longer? I don't know. Oh, okay, I need to hold it shorter. So I need to tap it, and then it turns on and off. Now I don't know what the other buttons do actually. Oh, okay, oh cool. It also turns it on and off. Oh no, wait, it changes the effect. If you look at the effect list, oh, or change it to breathing, I guess. I don't know. What does button 3 do? It's unclear. Yes, the next time the An-Penta-Mini will be available, Dr. Z's will also immediately have them. No worries. So I don't know what the standard button definitions in WLED do. I never really looked into how to configure that, really. It's a good question. What do the buttons do? Oh, Tom Square is here. Time and macros? No. So I know you can set them as a push button, but I don't remember where you set what kind of effect or change it should do. Does anyone know? Cool, Philip, thanks. Yeah, I don't know where to configure the buttons. Yeah, the problem is with WLED, you're limited to 8-bit dimming, and with the An-Penta-Mini, you can easily go up to much higher bit depth, but you need ESPHome for that. User interface? No. Time and macros, okay. Clock. Macros have been moved. Oh, here we go. Push button 0, 1, and 2. Short on off. Long off on. Double. But then, what does that do? Action 3. Oh, okay, don't need that. Is it like playlist 3 or preset 3? Yeah, it makes sense that it would do presets. So let's make some presets real quick. We want red. Okay, we need to turn it on. Solid red. No white. Add preset. Let's call this one red. And it's ID 1. Let's call this blue. And it's ID 2. And let's do green. And that's ID 3, right? So you see the ID here down here. Okay, so let's go to config, time and macros, and let's say that button 1 does 0, that's on off, I think. And let's say that this does 1 and this does 2, but that a double tap on button 2 is 3. Makes perfect sense. So let's see here. If I do 1, this is off, on. Okay, red. Blue, double tap. Double tap. Green. Okay, go back to red. Blue. Double tap. Green. Off. Okay, that actually works fine. Yeah, the analog button took me to a configuration wiki article unit, so don't know what that is right now. So basically, with this ground wire tapping on the screws of button 1, 2, and 3, we've verified that all the buttons of the An-Penta-Mini are working, right? And we can make it do whatever we want in a preset. So let's hook up some buttons. So let's turn the power off, because that's dangerous. And we're just going to do it jank style right now. We're just going to do it outside of the case. We don't need to close the case. Now, we have this ground wire, and we need ground on each of the terminals. Okay? And we need to determine what's an incoming side and what it connects to side. Now we have the 23 number here that we want to use because that's normally open, so not connected. And then once you hit the button, it gets connected to 24 over here. Oh, let me close the interface. So what we need to do is we need to hook up ground to each of the 24s so that when the pin gets shorted, it gets connected to ground. So what we could do is, let's see how many. I have some scrap wire here. Well, let's just take this. Oh, okay, this is red. I don't like this being red. That's kind of nitpicking, isn't it? Do I have a longer black wire? Oh, this one actually has a fork terminal. Nice, we can use this one. So we're gonna screw this black wire here. Wait, if the button pins are just ESP pins, what's stopping me from hooking them? These pins are generally input only. The pins I use on the ESP32. There's no level shifter on there, and there's a different circuit on there, actually, which does a pull high and debounce. So hooking up an LED to that will not work. Okay, so now let's hook up this to ground. Like so. Forks work really nice here. I like fork terminals or crimps. Okay. Okay, that works. And we need another wire. Let's use this red one, and we'll hook that up to button 1. No, didn't push the wire in. There. Okay. Okay, so we can connect this side already. And then, well, this is going to be a mess, of course. So, ideally, you use a bit longer wires. Ah! Damn it. Okay. It was more stuck than I thought it was. So, let's connect this over here. Okay. So again, to resume, okay, let's do it like that. If we look here, we have the button 1 pin, so the B1 pin and ground. We have B1 connected to, well, what they call 23 on this side, and then we have ground from here connected to 24, what they call it on this side. This switch, as we tested before with the multimeter, normally is not connected on the green side, but it is on the red side. So now, if we turn this mess on, we already configured the button pins, so let's turn that on. Okay, now if we push this button, it should be this one, it turns off. And if we push it again, turns on. And that's it. That's how you hook up a button. I mean, yeah, it's pretty easy. But now let's say we want to have all the buttons. Okay. We're going to cheat a little bit. Because we have this ground here, and we don't really need like a very strong, powerful connection. We just need a little bit of ground. So I'm going to unscrew this, and I'm going to squeeze this one in here, and then I'm going to screw it back, because we're going to steal, there, that should be sturdy, we're going to steal that same ground for all the connections. So let's rip this off. I don't know what this is, or some kind of cap. We're just going to take those off. Oh. Come on. There we go. Good. So we need this one. And we're going to put this wire in here. It's a red wire. It should be black, you know. Do I have another random? I have another random wire here. It doesn't need to be much. So I'm going to squeeze this in here too. to link to the ground to another part. There. Okay, that's in there. Good. So then we're going to connect it to this part of 24. No, I know, but we're just doing a mock wire up. I mean, yeah, normally you would do that, but it's more to demonstrate how to hook up the wires than how to make a pretty box, basically, right? Because, I mean, I did this wrong, too. So now we have 3 wires hooked up to ground, but we also need the other side. But I happen to have this here. So this is another random set of wires. So let's screw that in here. These are literally just random wires lying on my desk. So we're going to insert these. Thank God it's Friday. You had a long week there, Dave? Okay, those should be in. Yes. So that's button 2 and 3. So we are also going to hook that up to 2 and 3 here. But then the 23s on those buttons, right? Okay, so we had red first for button 2, so let's do that over here also. Did I not unscrew it enough? Okay. Now these button connections, although these buttons can take up to 10 amps, they say, what we're running through them is like 1 milliamp maybe. So the size of these wires really doesn't matter at all. Okay, so now we have button 1 hooked up here, button 2 hooked up here, and button 3 hooked up here. As you can see, they're coming from down there. And then we have a ground going from here up to here. And then I've basically daisy-chained that all here, so because it's all ground, doesn't really matter. Don't have to run 3 ground cables, basically. Okay, so let's turn this around. Okay. Nope, other way around. Let's turn on the power. Right, so button 1. Oh wait, what is button? Oh, okay, I need to turn it around. Turn it around. Sorry. Button 1 should turn it on or off and on. Okay. This one should turn it red because it's a green button. Makes total sense. It does. Nice. And then this one should make it blue, except if we double tap red, it makes it green. And then we can go back to red, or blue, or green, red, green, off, on, red, green, blue, red, off, green, red, blue. Okay, this is too far. Okay, anyway, I'd say that's working. What do you guys think? Disco, yeah, you can be your own DJ if you want to be. That's basically what we just created. We created our own DJ console. Red, green, blue, double. Oh, there's no double tap on this button. Okay, sure. So yeah, that works flawlessly. What happens if we go to green and we press 2 buttons at the same time? It's confused. It tries to do both, but it can't. Long tap the red button. No, that doesn't do anything. Nope, long tap doesn't do anything because we didn't configure it. More than 10 seconds, well that would have to be this one. And that might actually reset the Wi-Fi configuration, maybe. But long tapping this one doesn't do anything because there's no action configured. But if we tap it normally, it works fine. Double tap. Huh. Yeah, I know it resets. So yeah, that's kind of what I wanted to show today, but we've only been going an hour. So we could actually try and do the same with ESPHome and then configure some additional functionality, such as fading up or down. I mean, I think that's interesting. Blue. More blue. No. Green. Red. Green. Blue. Red. Off. Yeah, exactly. You have to have the right code to, you know, pass the next level or get the cheat codes. A pressure sensor to activate stair lighting. I guess so, unless... So you'd have to make sure that the pressure sensor would send a momentary press. So like that. Instead of a holding press, basically. Because then otherwise it might react too slow. I'm not sure. So, no, you can buy these on Aliexpress. These are just random boxes with buttons I got. Right? You can put a peer on it. Yeah, you should be able to. Yep. Yeah, but anyway, this was to demonstrate the button functionality that's built into the An-Penta-Mini. You can connect, you can connect them directly to the board. So now let's do the same thing, but then in Home Assistant. We have to reflash everything and stuff, but... So for now, what we can do is we can just pull out this green plug. And our whole button assembly has been disconnected. Nice. Okay. Let's turn off 48 volts, because that's always a bit scary. Philip wants me to try and flash the board again. So let's see what he did. Let me connect it to USB. And in theory that erases it, so it will also lose my Wi-Fi configuration, but that's fine. So connected. Okay, we need to hard refresh this. Control F5. Okay. Install. Connect. Install. Yes. Ah. It couldn't... Oh, wait. I'm not showing you anything. For some reason, it can't initialize. Is the page still the same, or do I need a different page? Oh, wait. That's not the right button. Okay, well, I'll look it up. Okay. Install. Why would I have to latch the boot pin? Huh. It's interesting. Shouldn't have to do that. That's only a extra emergency measure. Do I have an... Okay, I'll have to make a new one. Do I have another wire here? No? I thought, okay, maybe I'll just pull off this crimp. It's... Nope. It's not go. Damn it. Okay, we'll use this one. It's a temp page. Okay, sure. Normally it shouldn't need that, but we'll fix that later. Do I have a screwdriver somewhere? Yes. Okay, so let's make a boot button again. I don't know if this will fit. No, okay, so what is this? 14 gauge doesn't fit in these terminals. Where is my bucket of spare wires? Hold on. So on my desk I have a bucket of random connectors. But I also have a little box of short wires, which has all kinds of random crap in there that I've used at some point. So, no. Nope, this has a ring on it. This one. No, fork on it. Oh, here we go. The cutesiest tiny little wire. Okay. Ground. Button 3. I don't think I even have to screw it in. It's held in by friction, so let's go. Okay. Let's try that again. Install. Okay, it doesn't understand. Connect. Install. Install. Ah, there we go. Okay, I'm not sure why that's needed, but we'll figure that out. No, Tinty Killy, there is a circuit in there that will prevent backfeeding the positive voltage over USB. So you can actually have the main power supply and USB connected at the same time and nothing will blow up. It also won't charge your phone, sorry. Okay. Well, I'll just show you that it's booting, I guess. Hold on. Because we want to flash it with ESPHome anyway. There. Okay, let's turn it on. So now we should have a WLED AP again. And turn orange, I guess. Oh, right. Sorry. So let's do something you shouldn't do, especially 48 volt. Let's hot plug it. Zap. There we go. We got orange. And we got the WLED AP again. So that means it's indeed erased and flashed. Cool. So let's get my stupid wires away. Yeah, exactly, Philip. Okay, there. So how am I going to do this with ESPHome? I guess I need to write a little temporary configuration real quick and get it on the network, and then we'll configure the button stuff together. So let me work on that for just a moment, because I need to look into my test Home Assistant install. I need to create a new. Oh, I guess I can show you. No, I need to see if there's passwords in the configuration. Hold on. Hybrid, no. An-Mini, yes. Yeah, sure, Dr. Z's did it, that's true. So I think we can reuse this configuration. Yes. Let's see. Wow, this mouse is really annoying with scrolling. Anyway, I'll be almost there. Almost there. Hold on. This doesn't need to be here. This is fine. This shouldn't be here. This shouldn't be here. Yeah, this is fine. This is my testing password. Okay, save. We'll go through the config in just a minute. I just want to make sure I can actually get this compiled and flashed. Can you daisy chain the switches so each are at the end of the room? I don't... Oh, it failed. Okay, retry. What do you mean daisy chain? What? Oh, okay. I removed something from the project and then ESPHome gets confused. So then I have to say clean the build files. Okay, and now I can say install manual. We'll run through the config in just a minute. I just need to make sure I can connect to it, and then we're good. Yes, I use Home Assistant for all my lighting and house automation needs there at Tintikilly. But this is my testing Home Assistant install, so it has stupid passwords and whatever. My real install is my production install, and we don't get to see that. So let's get this working. Okay, success. Right, so I need the ESPHome web because I don't have HTTPS. I want to download it in modern format, and then for some reason my browser blocks it, so I have to say keep. Okay, so then we take the dimmer, connect it to USB again. I don't have a compatible plug here. There. So now we can say connect to that one, install, I can choose a file, the one I just prepared, install. Yeah, it does it without the dongle. See, no dongle life here. But that's probably just a setting or something like that. Okay, so that should now be flashed, so I can attach my antenna again. Yeah, it might be, Philip. We'll figure it out. So let's connect my LEDs again. Okay, let's put those over here, I guess. So we don't have any buttons connected right now, but I just need to make sure I can find the device. So turning on the 48 volt. And it should have this IP. Let's check it. Yeah, it has the same IP as it had before, but now with ESPHome on there. And this has some random configuration. In theory, I should be able to do... Okay, so this is the first channel. This is the second channel. This is the third channel. It's kind of reversed, but that's okay. We have warm white. And we have cold white. Okay, good. Okay. It's giving me some error. Oh, that's probably because WLED in the web browser was still talking to it. Anyway, so we have something we can reach. Now I'm gonna cheat a little bit because I have to change the configuration and then say use IP address, and I want to use this IP address. Oh, why is there no... I hate this on ESPHome. You can right click, you can say copy and cut, but you can't paste. Why? Why are you like this? Anyway. Oh, no, don't do that. Okay, yeah, that's fine. Save. So let's run through this config real quick. This isn't the end-all, be-all config for can't I zoom? Or can't I zoom? There. For an An-Penta-Mini, but this is a good starting point, I think. The people on Temu are going crazy about other people's work? What? Yeah, I used to have public schematics, but not for a long time already, because that didn't really help with people ripping off the work and then trying to sell it as their own. So, yeah. So if we look in the ESPHome configuration, we have a substitution. And the substitution basically says that it has an ESPHome name, and this is its ESPHome name. What you can do with that is, if we go to the second section, ESPHome, instead of name and having to type the whole name again, you can just type this substitution, and it will automatically fill in the name we've configured over here. Then we need some platform I/O configurations and how to set the flash mode in DO mode. Doesn't really matter, just copy that. Same with the ESP32 section. You just copy this. You can use either the ESP IDF or ESP Arduino. Whatever the features you need work with. We have the logger enabled, so if we're on the website we can see the logging and stuff like that. We have some Home Assistant stuff, so we're allowed to make an API connection with the password no hacking here, which just for my test systems. We're also allowed to do OTA with that password. And ESPHome gets the time from Home Assistant once it connects to Home Assistant, so that the times of your boards are always in sync with your Home Assistant. Then we have some Wi-Fi credentials, so the SSID and the password. Those are in my secrets file, so you don't get to see those. And we say that it has this IP address because I don't have MDNS and I have multiple subnets and blah, blah, blah. So otherwise it won't work. So I can just say, okay, it has this IP address. And normally what I do is I reserve it in my DHCP server and make an entry in my DNS server. And then I don't need this, but you know. We have a fallback mode, so it opens an access point if it can't reach the Wi-Fi network. Then it has a web server. You already saw that real quick. That's this guy basically, right? I have I2C configured. So if you look in the pinout guide on the Quinled website, you can see that the GPIO 6 and 7 are for the I2C. So we have that configured. Then we have some sensors. We have an internal temperature sensor, a system uptime, and a Wi-Fi strength sensor. Those would also show up in Home Assistant, but we currently don't have it linked to Home Assistant because we're going to use local buttons. But if you look at the website, you can see the current Wi-Fi strength is minus 62 dBm. You can also see the current temperature is 35.8. That's an internal temperature sensor of the ESP32C3 that's in there. And if we then continue, we get to the more important section, and that is this binary sensor. And that sensor is for our GPIO buttons, basically. So we have button 1 on pin 2, button 2 configured on pin 8, and something we call button 3, you can call it whatever you want, on pin 9, kind of just the same like we did in WLED. Then there is a switch, because I like having a software restart button in Home Assistant. So I configure the switch and then you can just hit the button and the ESP restarts. We configure the outputs. Now this is probably reversed, but I don't really care for right now. We configure the GPIO pins for that. Again, you can find those in the pinout guide. We configure a frequency. That is how fast the PWM dimming is happening. In this case, it's almost 20 kilohertz, because if you stay just below it, you can do 12-bit dimming. So it makes the dimming a lot smoother, for instance. Okay, and then we configure lights, and those lights are our outputs, also like you'd see in Home Assistant. We have them configured as per channel, so LED channel 1, LED channel 2, etc. And we have configured that each transition should take 3 seconds, and that's where that bit depth comes in. So let's keep scrolling. Then we have an RGB WW light, which is RGB CCT, but I've kind of named that wrong. I don't know why, but you know. There you can define red, green, and blue for the channels, cold white and warm white. You can set the color temperatures to match your strip. And I've defined some effects just for the fun of it. So we're not going to work in Home Assistant today. This would also show up in Home Assistant if you connected the board. But currently, we're going to work on having the buttons over here. Sorry, the scroll wheel really sucks. So let's say the button here, button pin 2, we can add. So right now there are buttons, and the state of this button would be fed to Home Assistant. And then in Home Assistant, you can have it do actions on this board or any other board in your Home Assistant install. But sometimes you might... Can you configure multiple lights per output? You mean for one button? Sure. Anyway, sometimes you don't want Home Assistant to take the action, but ESPHome itself, so on the device, and then report it back to Home Assistant, whatever happened to whatever light or things like that. So even that when Home Assistant isn't there, you can still use a physical button to control the device itself, even if it has no more network connection or anything like that, right? So we have the binary sensor. That is basically, it can sense on or off, nothing in between, but it can sense length. Sure, you can configure that if you want, Tintikili. So that's GPIO2, button 1. And we can enable a on press, right? So on press light toggle LED 1. Okay, let's save that, install, and flash that to the device. Let's hope that works. There it goes. Noise. I love wireless OTA. Okay, so that's started up. We can keep that open, I guess. Let's take our button assembly that we just made, and let's plug that in. Shouldn't be a problem hot plugging this, because there's not a lot of current or voltage involved. So now we have our buttons. And let's press button 1 and see what happens. It becomes blue. Press it again. There. You might be able to see that or not, but this fade already is a lot smoother than what WLED was able to do. Okay, so that works. And this button. So you see the button state on, off, on, off, on, off. You see the button states, but there's no actions configured to it on ESPHome. So if you'd have it connected to Home Assistant, it would also see these button presses, and you could do an automation there. But this one, although it will get sent to Home Assistant, is local on the device and doesn't need Home Assistant to function. How many amps are we burning on the strip with 48 volt and cool white? Well, we can check that out. So our idle power right now is 1.5 watts. This is cold white fully on. 34 watts. So about 30 watts, let's say. And now if we press the button, blue also turns on. Now we have 56 watts. So let's turn blue off again. Doesn't influence the other thing. Let's turn that off. Yep. In theory, it uses the same wattage because it's just spread over more LEDs, basically. Okay, so that was a very simple on-button press toggle LED 1. And that works beautifully. But let's see what else we could do. Well, we could do this on button. Why is this not correct? Oh, this is not correct. How did this get out of line? Okay, yeah. We could do on button press toggle LED 2, but that's kind of boring. So let's see in the ESPHome documentation. Let me look that up real quick. One moment, please. If we look at the ESPHome documentation and we look at binary sensor, that's the the sensor we're using, and we have an on press, okay, or you can do on release, on state, on click, on double click, or on multi click. So those are all options you can set. But we'll do on press, and we don't need to do any debouncing because we already do that in hardware. I want to see if we can raise the brightness or lower the brightness, basically. On double click, timing, condition, lambda calls, no. Hey there, Peter Schmidt. So let's see how we do that. I don't actually know. So the binary sensor component, okay, sure. But I wanted to do something. Light action. We need this one, I think. Yeah, light turn on. Okay, sure. Light turn off. Light control. Okay, what does that do? Oh, combination of on and off, okay. Light dim. This action allows you to dim a light that supports brightness by a relative amount. Okay, I think that's cool. So let's steal this part of the code. And let's go back to our ESPHome here. And then for button 2, on press should be this one. So if we push button 2 on press, it's going to, okay, we need to steal this ID here. It's going to increase brightness with 5%. Can I also decrease brightness? Let's try and build that ourselves. So on press for the next one, for button 3, can we say minus 5%? Okay. So back here, button 1 will toggle LED 1 on or off, right? Button 2 will raise LED 1 5%, and button 3 will dim LED 1 5%. I don't know. Save. Install wireless. No, that's not allowed. Okay. Something is bad. Seemingly we can't dim negative values? I don't know. How does that work? Awesome, Peter. Glad to hear the dip switches did the trick. How do we... So let's see again. So let's see what they say over here. Oh, not much. What can we do in negative? Dim. Has anyone ever done a negative dim? Because this seems to be a positive dim. Increases brightness by 5%. Okay, yes, good. But then how do we decrease it? The relative brightness to dim by, if sure. You need an if clause. Hey, Dutch Makers here. An if clause with positive and negative dimming. But, I mean, I'm just trying to define two buttons, right? This button should raise the brightness and this button should lower the brightness. Some wrong index, okay. This is lined up. This is lined up. This is lined up. Oh, this isn't lined up. Oh man. No, wait, it was. Was it? Did that fix it? Maybe. Oh, there's still red here. No, okay, something's wrong. Let's say I do this. Does the red go away? No, it doesn't. Huh. Where's my error? Okay, that's all default. That's all what I had. Yeah, okay, but I'm gonna put my minus back then. There. Save. Install wirelessly. Line 68 and 85. Okay. So, they're both... No, okay, this was 68. Okay, let's try now. 68 and 91. Okay. So we have a binary. Okay. This should be that. Ah, okay. Now we might be getting... Ah, there we go. Man, this stupid indenting. Okay. Okay, should be uploading. Yeah, that's true, but, you know, Okay, so it should be booted, but the default is doing nothing. Let's try button 1 again. Okay, it fades up in blue and it shows it on the screen. Turn it off. Good. Let's go to button 1 again, but then hit button 2. Let's hit it some more. Oh, the brightness is at 100%. We can't hit it more. It's not going to do anything. Let's hit it, the button 3. Now we're at 95%, 90%, 85%, 80%. Let's hit it a few times. Let's go to 30%. There. 20%. Cool. Okay, I need more. 30%. Okay, let's turn it off. Turn it back on again. More light. Give a man a button. I mean, he's done. Oh yeah, very smooth. Yeah. This is a 12-bit depth, so, you know. Yeah, you might want a less noisy button, but this is just an example for a button. You can use any type of button you want, right? But we can still improve this by saying on press. We can make it so that if you hold the button, it'll go higher, and if you hold the other button, it'll go lower. Can we also keep it pressed in the current version? I don't think so. Let's try it. No, in the current version, it doesn't understand that because it only registers on press, not on hold, right? So, is there a on hold? Binary sensor, on press, on release, on state, on click, on double click, on state then, I guess. Yeah, does something when a state is published. Okay, so then this should be state. But then what else do I need? See, on state. Will be triggered when a new state is received, thus combines on press and on release into one trigger. The new state will be given as the variable x. Okay. But then how do we keep it on dimming? No, it doesn't do that because this, see, this is not, it will only do it on click. So, oh, actually we need this one, on click. We're just right here. So let's copy this. No, wait. If you then need to hold it for a certain time, but it doesn't dim up or down. On multi-click. Part of this is already on the An-Penta-Mini website, or the Quinled website in the An-Penta-Mini section. This is just, you know, the normal ESPHome documentation. You can find these things. Yeah, I'm wondering if we can automate dimming up and down. Oh, you can do auto repeat. Okay, how do we do auto repeat? But where do I put it? Let me see if there's an example for auto repeat. Auto repeat. There. Oh, okay. You just put it in there? Okay. So then, wait, where do I put it? Filters, platform. Do I just put it here? Feels weird. Like that? Nope, it's erroring again. So the first batch didn't make it to the US, the second batch will, and we are currently reproducing. But it'll take a while before that's done, another 2-3 weeks. Because it got sold out really quick. Auto repeat, delay, okay, yeah, sure, but I don't care. So I need to add a filters maybe? Oh, that's it. Okay. So I need to add the auto repeat in the filter section next to the invert. So let's see if that works. Save, install wirelessly. Okay. Uh-oh. Oh, okay. It was just rebooting. It's like, oh man, I shorted something. So let's turn it on. Okay, that works. Good. Oh, okay. So this should still do the same thing. Brightness by 5%. But if I hold it, yeah, it does it. See? It's a bit slow. These seem off, but they are actually on. I know you can't. Why can't my camera see that these are on? Oh, there we go. Okay, they're very low. Let's raise the brightness. There. Yeah, there's a bit high delay on there. We can edit that by auto repeat, and then we can say delay. Let's see here. We have to go here and then delay 0.2 seconds. Now this might all seem very complex, but basically you only have to do this once, and then you know, you can do this for all your lights. Big voltage drop? No, there's no voltage drop. What? Yeah, I don't know if this is the way to do it, but this is the way I figured it out during the live stream. That's not always the best way to do it, but it's a way to do it. Right, so let's turn the light back on. There. It goes up to, well, let's wait for the logging. Okay, it goes up to 100%, so now let's lower it. Okay, it's still a bit slow. And this transition time is also very long. Yeah, I don't know if that exists, Philip. In theory, I guess. So this is still too slow. So we need to add more configurations. Edit. Delay. Oh no. So let's make it 200 milliseconds. And time on is 500? I don't know. I don't know how this works. We'll see. Oh, no. I'm sure someone online has written some kind of guide, and otherwise I'll write one point. Voltage drop on the LED strip? No, this is 48 volt LED strip. There's no voltage drop. Well, even if it is, it's very minimal. Okay, let's wait for the logging. There. Let's turn it on. Did we increase or change the behavior? That's a little bit faster now. There. That's the value I want. No, okay. I need to go lower. That's the value. Okay, we need to change this transition time because that's taking way too long. I think we can put transition time also in our actions. No, not over here. Transition length. Okay. Relative brightness. Transition length. Very, very fast. Save. Install wirelessly. Someone in the future scream, "What are you doing?" Yeah, well, we're configuring buttons in ESPHome to do all kinds of weird stuff. Probably the wrong way, but we don't care. Okay, let's wait for the logging again. So what we changed now is that we changed that the reaction time for changing the brightness 5% is only 100 milliseconds, 0.1 seconds. So let's turn this on. This is still the normal transition time because we didn't change that. And now let's hold this. Oh, now you can see it changing. Because it's changing really fast now. Oh yeah, especially if I hit the buttons. Yeah. So that kind of works. I'm not sure this is the right way to do it, but it at least shows you can configure the buttons to be very flexible in what they do in ESPHome. That's basically the idea. So maybe this needs to be 200 milliseconds and this needs to be, I don't know, we're just going to try it. And then this needs to be 0.2 seconds because it's too fast. There. I'm just going to play around with these values now. Now trigger RGB CCT effects. Oh, you can do that too. That's no problem. Exactly. These buttons should last a while. They can handle up to 10 amps and we're using them for 1 milliamp or something like that. Okay, so let's turn this on. And now let's hold the red button. Oh yeah, that's much faster. Yeah, that's good. Okay, up. Down. Yeah, that's better. That's better. Now you can easily regulate what you want it to do. And you can immediately see the impact of it. Yeah, that's pretty cool. Cool. Nice. Okay, so Philip wanted disco effects, right? Because one thing I did configure is, let's turn channel 1 off there. And let's turn on this channel, but it's going to turn on all the channels at the same time. But I have my totally loco, you can't see that, totally loco effect here, which is going to go through all kinds of random permutations of effects. Well, you can tune it the way you want it, Dutchmaker. If you want it more smooth, you can do that too. Yeah, so if we look at the code, oh god, this is how fast it's changing. Every 0.3 seconds, it's going to a new random value on all of the channels at random brightness. Sure, you can configure that. That's no problem. So, the way it's currently configured, I have the RGB WW lights here, which have all the channels configured. And then you can define effects. So this one changes in 60 seconds, this one changes in 30 seconds, this one changes in 10 seconds, this one changes in 1 second, and this one changes all the channels and all the effects in 300 milliseconds. Which is kind of nuts. If you do it like this, it is very smooth. So these buttons are, well, they're connected to GPIO pins, but those GPIO pins do have a hardware pull up and debounce. But you want to control an ATX power supply. Using these buttons, you mean, or? Because these are momentary press. So I'm not sure what you're going to do with an ATX power supply with that. So currently these lights are changing. They're very hot because they're like very white. There. And I can see the wattage change, but you almost can't see the lights themselves change because, well, it's so slow. And it's still set to fast. But because it has lots of steps, so lots of bit depth, it can do it very granularly. These, no, I don't think these have a great CRI. Yeah, okay, let's see. Can I turn that down? Yeah. Yeah, the problem is that the whites are also doing all kinds of stuff, so you can't really see that changing. Well, now you can see it change a little bit. I'm not sure what you'd like to control from an ATX power supply with buttons there, Richard, so I don't really know what to tell you. No, Dutchmaker, these probably have horrible CRI. I bought them because they're a 48 volt strip, that's it. Yeah, we can still use the buttons. Okay, well that's giving conflicting messages. I'm turning on the same channel twice. Let's not do that. Let's go very fast. That's more visible, I think. Yeah, one of the advantages of running almost 20 kHz PWM, you have not seen any PWM flicker on the camera. And this is only running 20,000 kilohertz. We can easily run 40 or 80 or even higher if you want to. And no noise. Power supply isn't making any noise. My dimmer isn't making any noise. It's as much as a no noise dimmer as I could build. Right. How long have we been going? 2 hours, okay. They want their button. What's wrong with my buttons? I like my buttons. They're great. Yeah, but this is just to show that if you have a random type of button, could also be a wall button that you hook up to the An-Penta-Mini, you can make those buttons do, well, whatever you want. Either on this controller or so locally. So no, we're not connected to Home Assistant. Everything here is done locally on the controller. Or if you do connect it to Home Assistant, you can make one of the buttons do something on another dimmer or on multiple channels spread over multiple dimmers or whatever. But if you then have a power outage or something else is going on and Home Assistant isn't available, well, then you still have the local button, which will keep working. Secrets time. Oh man, I didn't prepare any secrets, but I am kind of done. I was a bit tired today, so we are going to end the stream soon. Do I have a secret? Not right now, actually. I have lots of stuff that's going on, but nothing of it has arrived yet. So otherwise we might have also had a different subject. So yeah. Okay, it doesn't like two channels being on at the same time. Okay, that makes sense. How can you not prepare a secret? I know. Let me think of something. Well, diff power is in the works. I have prototypes that should arrive next week, maybe the week after. The dig to analog plus is in the works, which will add 48 volt support, at least 5 amp per MOSFET, and more output for the board, a replaceable fuse, etc. I'm working on a temperature sensor plug-in replacement for the analog boards, the other analog boards, and the Dig Octa. I have a version 2 brainboard prototype of the Dig Octa brainboard. I don't know. There's all kinds of stuff going on. Oh, you're visiting Netherlands again. Nice. So we're making a 14 or 15 channel and a 5 channel analog dimmer. The 5 channel will be a high power one, so you'll be able to do 10 amps for a single MOSFET and also have doubled up output terminals, so you can do power injection with those. And that board also has Ethernet, so if you want to hardwire it, you know. And then there's going to be another variant that has 15 medium power channels. So this one is 5, of which 2 are medium power. That one will have 15 medium power channels. So you can make all kinds of crazy combinations with lots of white strips, whites and RGB, RGB CCT, all the combinations. And both of those have gone into production this week. So first it's PCBs, then it's manufacturing, then we need to figure out the software and the testing jigs, and that kind of all happens in parallel. But it'll at least be, let's say, 3 weeks, I hope, maybe, before those are done. What can we do for the 100th live stream? Who knows? Who knows? Yeah, I just mentioned it. Mao. Do I have it here? No, I don't have it here. So this was a prototype for a 15-channel analog board. The real version changed a little bit, but that one's coming. And there will be a 5-channel one with high power channels, which will also have Ethernet. So that is coming in the same time frame. There's 2 extra boards. So for the 100th live stream, I have some ideas, but I still need to work those out.
Very much alike.
I'm always planning an EU store, but it's more difficult than you'd think, Bugo. Maybe at some point, Dutch Maker, but not during the 100th live stream. But you can scroll back there, Chaftali, and look at all the fun stuff. We configured buttons, and we have these giant buttons, and they're great. Yeah, I think with some squeezing, if you just use the PCB, you could actually fit the An-Penta-Mini in the housing. and then have the LED strip come out, and then it's one hole. But you know, whatever floats your boat. So I guess that's secrets that I'm working on, all kinds of stuff. I'm waiting for like 5 or 6 sets of PCBs to come in, and components, and partially assembled stuff, and things I need to assemble myself, and lots of things going on. Oh, and Diff Advanced. We got the first Diff Advanced built boards back from manufacturing. So those are coming out next month, I hope. No magic smoke this time, sorry. Even the 48 volts has been working fine. You can see these changing colors. On my hand, at least. Yeah, no problem. So yeah, 2-hour stream. Bit short for my doing, but I think we'll leave it at that. Thank you for watching and hanging out with me. And I hope to see you back on the next video, in the YouTube comments, on the next live stream, or maybe in the Discord server. Thanks for watching, guys. Bye-bye.